All right. The purpose of this lesson is to discuss how to solve a system of two linear equations. Oftentimes, we want you to consider two equations at the same time and how they're interacting. We will draw a large bracket, curly bracket, around them, in the front of them. So your goal for this particular problem is to find where these two equations have a point of intersection. And what that means is if we were to graph these two lines on some coordinate, which we'll do a quick sketch of here, you won't need to write this, this is just for a quick reference. If we were to graph these two equations, maybe the first one goes up like this, and maybe the second equation, maybe it goes downhill like so. What we're trying to figure out is where they share a common point. Now that point has, as a coordinate, an x value. There's some x coordinate here. We'll call it x1, meaning some x coordinate. And it's going to have a y coordinate right here. We'll say that may be y1. And we would then say that this point, if we list it as an ordered pair, would be x1 comma y1. So this is the coordinate we're trying to find. And it doesn't always have a solution. Sometimes your two lines, they run perfectly parallel to each other. And if that's the case, they're never going to cross, so it'd have no solution. In this case, they do cross, so we get one solution for these two lines. And sometimes the two equations they give you are the exact same line, which would mean they intersect everywhere along them, which they would have an infinite number of solutions. So our job is to see if this line crosses, and if so, what's the coordinate? What x value, what y value? So with that being said, go ahead and wipe down our screen here. Okay, very good. We're trying to find this point of intersection. There are two ways to solve a system of linear equations like this. So we're going to write that down. There are two ways to solve oof, that looks very, very rough. I am so very sorry. Maybe we can fix that in post. So there are two ways to solve a system of two linear, meaning lines, equations. So two linear equations. So here's one equation, there's the second. So there's two of them here. And there are going to be two possible methods that we are going to talk about. The first one we will talk about today. Okay, and that method is called substitution. So our first method we're going to list, we're going to write it here. We're going to say, okay, let's learn about method 1. So method 1 is called substitution. Oh goodness, that T is having a little bit of issues. Let's see if we can do that a little bit better. Okay, so substitution. This is where we are replacing something with something else. So a little note to ourselves here is that we will say that we are replacing something. So replacing something. Okay, that's the goal of substitution, that we are going to be replacing something. So here's how it works. We take one of our equations, and it doesn't matter which one we start with. In this case, I'll just start with our first equation, and let's look at it for a moment. So if I look, it says that my y value is equivalent to 4x minus 12. Well, that means that anytime I see a y value, it could be replaced with this quantity, 4x minus 12. Right? And that's okay, because we're told that they are equal to each other. We know they don't look the same, but they have been given this symbol, which means we are being told they are the same amount of stuff. This is the equivalent of having two $10 bills or having four $5 bills. It's the same amount of money, even though it looks different. So this might be a single $20 bill, and here this is four $5 bills. So they have the same amount of stuff. This says that they're equal to each other, so we are going to accept that this is true. And that means anytime I see a y value down in my second equation, I can replace it with what this y is equal to, which is 4x minus 12. All right, so we're going to start off by writing this second equation as is. Let me change up the colors so we have something to look at. So here is our initial equation. We have y equals negative 2x plus 30. So that's that second equation. All we've done is copy it down. All right, our next step, so this is what we are doing. This is the big important thing we're going to do. We are going to replace, y with what y is equal to. So it's a bit sloppy. I do apologize, guys. I don't want to smear what's already been written. So maybe next time I'll just use ink on paper. That's fine too. Okay, so our job is we're going to take the same equation. Nothing's going to change on the right-hand side. So that's going to stay exactly what it was. So that side is still going to be negative 2x plus 30. Nothing happened there. But I'm going to replace this y value with what this first equation tells me y is equal to. It says y is equivalent to 4x minus 12. So where there used to be a y here, I'm now going to write 4x minus 12. And I'm underlining it to show, hey, I've done something here, right? I've got something that wasn't there before. I'm going to zoom out a little bit so you guys can see more of the notes. Okay. So where it used to be y, we've replaced it with what y in the first equation is equal to. And that's okay. This is the same amount of stuff, right? We haven't changed how much stuff. It looks different, but it's worth the same amount. This is why we know that. This equal sign tells us it's the same amount of stuff. Okay, so now that we've done that, you should notice we now have a different equation than we had before. This equation has just one type of variable. I'll say that again. Our equation now just has one type of variable. It just has terms that have x in them. Before we had two types of variables. We had an x, we had a y. Now we just have one type of variable, which means we can now solve this equation because it only has one variable. So that will be our next step. We are going to solve the new equation that has only, oof, that's not going to work. So we will have to be very careful how we spell that. That has only one type of variable. All right, now guys, this word is really important. I notice that most of you do not use math vocabulary, and that's because it's not familiar to what you use in your everyday life. You have to get used to, you have to change how you speak in your classes. You have to use your academic language. Variable, it's the same word in most languages, variable. It literally means the thing that can be changing, right? A thing that could change. We don't know if it's a 1, if it's a 12. It's some value that we don't know, but it could be any number of things. So this is going to be called a variable for right now. We could also call it our unknown, right? It's a value that we don't know what it is yet. Okay, so those are related terms. All right, so our job here is to solve this new equation. So we look at the equation and we say, okay, I need to combine any like terms. Well, there's no like terms on the left. That's a 4x, that's a minus 12. We can't combine those. And same thing on the right. We can't combine negative 2x and 30. Those are not like terms. 4x and negative 2x are like terms. So we learned about this last week. The way we're going to solve this equation is we're going to combine the negative 2x and the 4x, which means one of these terms is going to move to the other side of the equation. It doesn't matter if we move the 4x to the right or if we move the negative 2x to the left. It's up to you. I generally like having my x's all on the left-hand side. It's just kind of more pleasing visually. But it's not required, guys. The answer you're going to get will still be the same, no matter which side of your equation you move your variable. So let's move this negative 2x so that we move it over to the left-hand side. To do so, we need to use the additive inverse of negative 2x, and that would be plus 2x. So it's the opposite sign. So if we have a negative, this would be a positive, and vice versa. That was a positive 2x, we would be doing minus here. And what we do to one side of our equation, of course, we have to do to the other side to maintain this balance of equality. All right, if I take $2 off your plate, I got to take $2 off her plate as well in order to maintain balance. Okay, so this is going to go to 0. On the left-hand side, we get 4x plus 2x, so that's going to be a total of 6x on the left, minus 12 equals 30. All right, the positive 30, nothing happened, it just drops down. Okay. All right, we're going to do the same thing with our constant terms. We're going to move this negative 12 so that it's on the other side. Why are we doing that? Because we want to isolate this variable. We want to get it by itself. Isolation means to be by yourself. So we're going to get the 6x term by itself by subtracting 12, or sorry, by moving this minus 12 to the other side. So we do that by using, again, the additive inverse. The opposite of a minus 12 will be a plus 12. So we're going to add 12 to both sides. All right, 12 cancels out. We get 6x on the left because nothing happened to the 6x. Nothing changed there. Equals, guys, please make sure you keep that equal sign. You should always have, if you start with equation, you should be ending with an equal sign, an equation. And on the right-hand side, 30 plus 12 is 42. All right, so we're very close to a solution here. Our last step now is to get the x by itself. Now, from what I can see, this says 6x's equals 42. Well, we want to know what one of these x's equals to. So this number is 6 times too big, right? This is 6 times whatever x is will give us 42. I just want to know what one of these is, so I need to divide this number by 6. That is called the multiplicative inverse. All right, the multiplicative inverse, right? And it's the same thing as we were doing earlier with the additive inverse, right? Where we're doing adding or subtracting. Here, the opposite of multiplying by 6 is dividing by 6. So 6 divided by 6, this gives us 1, not 0, because you're dividing, guys. That gives you 1x. Now, that's what we want to know. We want to know what one of these x's is. And 42 divided by 6, I'll do the math, that is 7. Do you need to put this 1 out front? You don't. I'm writing it here to help you understand that we did 6 divided by 6, and that becomes 1. And if you don't want to write the 1 in math, we don't need this 1 to be out front. It's okay because it lets us know, what we did up above. But if you just have x here, we assume that that means there's one of them. This is not 0x. The 6 didn't just disappear. 6 became the number 1. And 1 times x is just x. So we have our x value. Okay, great. Now recall, I told you earlier that we're trying to find a point of intersection. So this is our x value, right? So our answer, which I'll put right here, let's see if I can scoot that up a bit. There we go. Is going to be 7, comma, and now we need our y value. That's the thing we don't have quite yet. Let me move that over. Okay, so we need our y value. Okay, so the last step is we are now going to take the number we've gotten as part of our solution, and we're going to substitute it back in to one of our equations. Does it matter which one? Not at all. Doesn't matter which one you use. So we are now going to, I could say plug it back in. So plug answer back into either original equation. Oh, that looks fantastically poor. I will edit that, guys. Give me just a moment. Let me use a different marker. I'm going to make that a lot cleaner. So I'll try to edit this video for us. So we will say substitute answer substitute answer back into one of your original equations. So substitute your answer back into one of your original equations. We're going to take this 7 and we're either going to put it in the first equation or the second equation. And some people really worry. They're like, well, does it matter? Do I have to choose one? Does it matter which one I choose? No, it doesn't. Because either way, it's going to be the point where it intersects. Best practice is actually to put it into both, and you're going to get the same answer out, and that way you know you've chosen the right x value. But it doesn't matter which of these you substitute it into. I recommend look for the equation that you feel is the least painful to work through. And that's the one you should substitute it into, and that's usually a pretty good rule to follow. So let's see here. I'm running out of space, but I can probably put this right here, and we can do the work. I was going to use it right here, but I ran out of my space ran out. I do apologize, guys. Okay, so let's see. I'll use my pens. Let's see. Here we go. So it doesn't matter which one we use. 4x minus 12 feels a little bit less difficult to work with than negative 2x plus 30. It's up to you, though. We can use either equation, and we're going to substitute 7 in for my x value. So we're going to write out the equation and replace the x value. Okay, so we got y equals, and I'm going to use 4x minus 12, so 4x. It's hard to write right there, guys. Let me see if I can move this over where I can. Okay, there we go. There we go. So now it's a little bit easier for me to make sure you can see what's happening. So y equals 4x minus 12. So that becomes y equals 4, and x is going to get replaced with 7 because that's what we figured out our x value is. And then, of course, minus 12. Notice the equation, nothing changed except for the x value. Everything else stayed exactly the same. The 4 doesn't go away. It's still there. So now we just need to solve this equation. We get y equals 4 times 7 is 28. And then we're subtracting 12. All right, so 28 minus 12, that is 16. So y should equal the value 16. This is our y value. All right, and I'm going to move this over here. And then we can write that on our board. This will be our final solution. Y equals 7, comma 16. And that's our process. So we're going to do some check for understanding with this video. There should be hopefully a Google form or a Schoology question or two for you to answer. I'm going to ask you for some vocabulary words we use today. So that should be very easy. You can watch the video to listen to them. But here's the lesson in a nutshell. We wanted to know where these two lines share a common point, meaning where do they cross if we were to graph them. We learned that there are two main ways that people solve a system of equations that have there's two linear equations. The first method we learned today is substitution, and that involves replacing something in one equation with what that thing is equal to. In this case, we said that y was equal to some quantity, so we replaced one of our y's with what the other y is equal to. Okay, and that's what we did here. We then solved for the new equation. We found out that x was equal to a specific value. It was 7. Once we knew that, we needed to substitute that value back into either of our original equations. And when we did so, we got our y value, which was 16. If you substitute it into the second equation, you're going to get the same answer we got before. You can test it. -2 times 7, that's -14. And 30 minus 14, I promise you that is also going to give you the value 16, guys. So feel free to check those. It's always okay. So this should be the longest video that you have to watch about this. We will do one more example, so that's going to come later in the same video. But feel free to pause and answer some of the Schoology questions if you'd like at this point. I'm going to continue on with our second example, which will go up quite a bit faster, I think. So let me go ahead and, here we are, go to our second example. Okay. Now, I believe I wrote this problem slightly different when I did this as a live session. That's okay. The answers will come out slightly differently, but they'll be a little bit more nice to look at. So I think everybody will be okay with that. So here is our second example. This will be example 2. And again, we are solving a system of equations. A system just means a group of equations, right? So we're using just 2 so far. When you get to Algebra 2, there might be more than just 2 that you're going to be solving for, and we will show you some really cool techniques for that when you get there. Okay, so we're going to have 2 equations again. These are going to be written slightly differently. So our first equation is going to be 5x plus 3y equals 10. And the second equation is y equals -3x plus 6. So here are our 2 equations, and this is called a system. This is a system of 2 linear equations because both of them, if we were to graph them, would would be two lines. They would be two straight lines. And that is why we call them linear equations, because when you graph them, you get two straight lines. Okay, so we are going to use substitution again. So our method, I need to change up my color scheme. Okay, so our method, and let's go to, the camera will pull this up very well. I need to pull back a bit. Looks like you're not getting everything into frames. Let's try that a little bit. Okay, I think that's a bit better. So our method here, we'll pull that over, there we go, is going to be called substitution, of course. All right, we're going to use substitution. And so, as before, we have to look and see if there is a variable that is set equal to some other quantity. In the first one, that's not the case. We have 5x's plus 3y's equals 10. So neither one of these variables has been solved for. But the second equation, we see that y is by itself. It says that y, this variable y, is equal to this rule, negative 3x plus 6. So we have a variable that is equivalent to another quantity. This we're going to use as our substitution rule. So in the first equation, every time I see a y value, I'm going to replace it with negative 3x plus 6. That's the goal. So we're going to copy down the first equation. So we got 5x plus 3y equals 10. So there's our original equation. We are now going to rewrite this equation again one more time, but this time we're going to replace the y with what this y is equal to. So we end up with 5x plus 3, and we're going to multiply 3 times y. So here we're going to multiply 3 times this new quantity. That new quantity, I'll write it in a different color so it stands out, is of course negative 3x plus 6, right? So where there used to be a y, there's now a negative 3x plus 6 from before. All right, and that is equal to, that is equal to 10. Right? So the equation, only thing that's changed, it was we swapped out that y and replaced it with a negative 3x plus 6. Some questions that might come up here. Mr. Duncan, why is there still a 3 here? Well, because this says that we had 3 groups of whatever y is. Right? We have 5 groups of x plus 3 groups of y. So that means since y is equal to negative 3x plus 6, I should have 3 groups of this. So I should be multiplying this by that 3, because that's what was happening before. So the 3 doesn't just disappear, okay? All right, so we have a new equation. Notice we have all just the one type of variable. We just have x's. Before we had x's and y's, right? Here we had x's and y's. By combining these two equations in a clever way, we've now got just an equation with one type of variable, that being x's. All right, so now we're going to use our order of operations to simplify and solve this. So first of all, I see that we have a 3 on the outside of this parentheses. We're going to distribute this 3 to both terms. We're going to multiply both terms by that 3. And here is what the result of that should be. We get 5x, because nothing's changed there, plus 3 times negative 3 is a negative 9x. 3 times a positive 6 is a positive 18. And on the other side of the equation, we get equals 10. Oof, my equal signs are suffering a bit, guys. I do apologize. Oh, we're going to get this right, Mr. Duncan. You're going to take your time, get it right. Good enough. Okay, that'll do. All right, so now we combine like terms. Hey, we have our like terms on the same side for once, so that's easy. We're going to just do 5x plus a negative 9x. So these get combined straight. You don't do any type of additive inverse because they're on the same side of the equation. You only do additive inverses whenever they're on different sides of the equation. Here, we just combine them straight up. I have negative 9x's, and I have a positive 5x. Obviously, since the signs are different, they're going to cancel each other out a bit. We're going to lose 5 of these negative 9x's. So we will end up with negative 4x, right? Negative 9 and a positive 5, that gives you a negative 4 when you combine them. Plus 18, we didn't do anything with the 18 yet, equals 10. Okay, we do need to move that 18 so it's over on the other side, so we will use the additive inverse. Okay, so the additive inverse of positive 18 is negative 18. All right, so we subtract 18 from either side. I'll change colors, guys. Hopefully the colors are working. Some people may have struggles with the color, and if so, then I can definitely choose just to work in black. That's okay. So negative 4x drops down, nothing crazy there, equals, and 10 minus 18 is minus 8 or negative 8. So hopefully that comes through. It's a little bit faint. That green is a little bit faint. It might be heading for the trash bin. We'll see. All right, and then lastly, we need to get x by itself. So the multiplicative inverse, right? The opposite of multiplying by negative 4 is dividing both sides by negative 4. And that will give us x equals positive 2. All right, so a negative divided by a negative, that's a positive, guys. And 8 divided by 4 is a positive 2. So our x value is positive 2. Okay, so I'll put that right here. We get 2 as our x value. We still need our y value. So we substitute in our newfound value of x into one of these equations, and it doesn't matter which one you use. This one that's in y-intercept form is probably the easier one to use. I would probably say let's use that one. It looks like the least difficult to work with. So I'm going to take this 2. I'm going to take this second equation, I'm going to substitute that 2 into that second equation. So I'll just put a little divider here, partition. We're going to copy in y equals negative 3x. Ooh, that x needs some help. Negative 3x plus 6. That 6 is looking a little bit, there we go. Okay. We're going to replace the x now with what we just solved and found it to be. We found that our x value for this problem is 2. Right, that's the value where these two lines cross. So everything else stays the same. Y equals negative 3. And now x, of course, we're going to replace it with the value positive 2. And of course, plus 6. We didn't do anything else to our equation. All right, we now simplify. We get y equals negative 3 times 2 is negative 6 plus 6. And that will give us y equals 0. Negative 6 and positive 6, those are additive inverses. They become 0, right? So that is our y value, is 0. So we'll put that down below. And this is our solution. And again, we're using substitution. All right, so big takeaways for substitution. You need to solve for one of your variables in order to use substitution, right? You got to get a variable by itself, and then you can use that to substitute it in for another for that value in the other equation. All right, so we couldn't have done this, and we couldn't have used y equals 3x plus 6 and did substitution with the top equation because we don't have a variable that's being solved for. We'd have to get the x by itself or the y by itself first in this equation in order to use substitution with it. This guy was ready to go. This says any place you see a y, replace it with negative 3x plus 6. That's very simple, very easy to do. All right, so that's the big takeaway for substitution, and that'll be it for this video. All right, you can now utilize your time to go and answer a few Schoology questions. Remember, go ahead and respond to the vocabulary. What are some vocabulary words we use today? And in addition, go ahead and solve a couple problems involving substitution.